Unveiling the secrets of sklearn's PLSSVD, a deep dive into cross-decomposition. The essence of PLSSVD. The partial least squares with singular value decomposition PLSSVD is a powerful multivariate statistical technique belonging to the family of cross-decomposition methods. It excels at revealing hidden relationships between two sets of variables, often with the aim of predicting one set from the other. This stands in contrast to classical regression methods, which only seek to predict a single output variable. Let's break it down. 1. Partial least squares PLS. At its heart, PLS aims to find latent variables, also called components, that capture the maximum covariance between the two datasets. This is achieved by iteratively constructing components that explain the maximum variance in both datasets while simultaneously maximizing their correlation. 2. Singular value decomposition SVD. SVD is a linear algebra tool that decomposes matrices into three components. A matrix of left singular vectors captures the variance of the first dataset. A diagonal matrix containing singular values represent the magnitude of the relationships between datasets. A matrix of right singular vectors captures the variance of the second dataset. Why use PLSSVD? 1. Handling collinearity. PLSSVD gracefully handles datasets where predictor variables are highly correlated, a common scenario in many real-world applications. This makes it ideal for situations where traditional regression methods struggle. 2. Multicollinearity and high dimensionality. It can effectively address multicollinearity and high dimensionality issues present in large datasets, often leading to more stable and interpretable models compared to standard approaches. 3. Predictive power. By uncovering the hidden relationships between variables, PLSSVD can achieve excellent predictive accuracy for both the original datasets and for unseen data. Key features of sklearn's PLSSVD implementation. 1. Flexible number of components. You can control the number of latent components to be extracted, allowing you to adjust the complexity of your model. 2. Scaling options. The scale parameter allows you to choose between scaling the data for improved numerical stability or leaving it unscaled, depending on your specific needs. 3. Data handling. The sklearn cross-decomposition PLS regression class readily accepts both NumPy arrays and pandas data frames, offering flexibility in data input. Application domains. 1. Chemometrics. PLSSVD shines in chemometrics for analyzing spectroscopic data, relating spectra to chemical properties or concentrations. 2. Bioinformatics. It finds extensive use in bioinformatics, analyzing gene expression data to identify biomarkers or understand biological processes. 3. Marketing and customer segmentation. PLSSVD can analyze customer data to understand buying behavior and create effective marketing strategies. Caveats. 1. Interpretability. While powerful, the latent components extracted by PLSSVD can sometimes be difficult to interpret, requiring further analysis to understand the underlying relationships. 2. Sensitivity to outliers. Like many statistical models, PLSSVD can be sensitive to outliers, potentially affecting model accuracy and stability. Let's illustrate. Python. From sklearn cross-decomposition. Import PLS regression. Import pandas as PD. Load your data. XPD. Read CSV. YPD. Read CSV data.csv. Instantiate the PLSSVD model with 5 components. PLSSVD PLS regression components 5. Fit the model to the data. PLSSVD. Fitx. Y. Make predictions on new data. Predictions PLSSVD. Predict new data. Access model attributes for analysis. Print PLSSVD. X weights for the X components. Print PLSSVD. Y weights for the Y components. Print PLSSVD. Y loadings for the Y components. Print PLSSVD. X loadings for the X components. Key takeaways. PLSSVD is a powerful tool for exploring relationships between datasets and making predictions. It gracefully handles collinear variables and high dimensionality, making it suitable for complex data. While powerful, interpretation of the latent components requires further analysis. Exploring further. For a deeper understanding, explore the documentation of sklearn's PLS regression class. https://skit-learn, org stable modules generated sklearn, cross decomposition, PLS regression, HTML https://skit. Learn, org stable modules generated sklearn, cross decomposition, PLS regression, HTML. Consider researching alternative cross-decomposition methods like canonical correlation analysis, CCA, for further comparison. Experiment with various parameter settings and data preprocessing techniques to optimize your PLSSVD model for your specific application. By understanding the principles behind PLSSVD and leveraging its strengths within the scikit-learn framework, you can unlock new insights from your data and gain a competitive advantage in various analytical endeavors.